Okay, good morning. Welcome to
SuperMath158a.
Today we're in the section studying three-dimensional objects. Oh, I didn't realize this was white against the white background, so hopefully it's not too hard to see. Can you hold this, please?
Alright.
So I just showed you a movie about a cylinder, and I made that movie at the Museum of Math earlier this week.
Yeah.
What did you notice about that?
Well, we had a cylinder, and there was this light that was shining under it.
Okay.
And it projected a circle in the middle. Well, it just projected a circle in the cylinder.
Okay. So as I was moving the cylinder through the light, we were getting circles.
Yeah.
Okay.
Well, a circle is a cross-section of a cylinder.
Mm-hmm. Definitely. So
But the circles didn't change shape or anything.
the circles didn't change shape. No. And so what does that tell you about a cylinder?
Well, that it's these are flat. It doesn't change, like it's not all wavy or bumpy on the top or bottom.
Okay, good. Anything else that you noticed?
Well, yeah, it stays the same all the way through. I said
It's the
that.
same all the way through, yeah. So what I want to talk about today is how you would make a cylinder. So one way you could make a cylinder is by stacking up all these circles on top of each other.
Yep.
Okay, so if you had, and how thin are these circles?
They're 2D thin.
Yeah, they're 2D thin. So you stack all these two-dimensional circles up, and you get a three-dimensional cylinder.
Yeah, you need infinitely many of them, though.
Yeah, that's true. You would need infinitely many, and that's kind of a problem. And so what people initially thought was, well, why don't we start with some really flat circles that just have some very, very minor thickness, just barely thick, barely thick. I forget, actually, Newton, this is what Newton did, and I forget what he called these, but it came to be, I think, from a German mathematician named Leibniz, I think. This thickness they call the dx, short for delta x. Delta means change, so you have a small change in x, and then dx meant infinitely thin. Okay, so you stack these on top of each other. And then when you stack all these cylinders on top of each other, all these small little heights end up
big height.
adding up to whatever this height is. Okay, so if you had 10 cylinders, each one has a height of h over 10. And if you have 1,000 cylinders, it's h over 1,000. And if you have infinitely many cylinders, it's
H over infinity.
h over infinity. Yeah. And so, for example, to calculate the volume of this cylinder, all we need to know is the volume of this little cross section, and then add them all together. But do you see any problem with doing that? So we don't know how to calculate the volume of a cylinder, but what if we calculated the volume of these small cross sections?
Well, we don't know that height either.
Well, let's say we did know the height of this small cross section.
Well, we know how to calculate the areas of circles.
Yeah.
So I think the area of a cylinder is just the area of the circle times the height.
Yeah, that's interesting. But wouldn't that same argument work here?
Yeah.
So it's a little tricky to calculate the volume of a cylinder using this shape, because what is this shape?
A cylinder.
It's a cylinder.
Yeah.
So this would be sort of a circular argument. But your intuition that you go find the area of the circle and then just move it up a little bit, whatever the height is an interesting one. And that does give you the volume of the cylinder. But we have to figure out a different way to do it. So can you see any other cross sections of this cylinder?
Not really, but what if you shine a light through it from like where the camera is?
Okay.
What would you get?
Well, the camera would be coming straight across this way. I think you would still get
Circle.
circles.
What if you shined a light this way?
Okay. What do you think? What shape do you think you would get if you shined a light that way?
So if you had a light like this and you shined it.
Yeah. What do you think you would get?
Well, you're probably gonna get something made out of straight lines.
Okay.
So there's there's this flat here.
Yeah.
Maybe you'd get a square.
Interesting.
Or, well, that might be the case if the cylinder were regular.
The nice thing about a square is you know how to find the area of it.
Yeah, and rectangles too.
And if you got a rectangle or a square as the base, and you went up a little bit on a height, now you have basically a box.
Yeah.
And you would stack a bunch of boxes on top of each other to get this. But the nice thing is you know how to calculate the volume of those boxes.
Yeah.
Alright, let's go take a look at the second video.
Alright.